Hi everyone and welcome to SXIVE Live. My name is Stefan Schütz, CEO of Solectrix, and I'm excited to give the launch signal today. When we created SXIVE, we didn't just want to build another image processing tool. We wanted to rethink it, to give engineers full control across the entire image pipeline. From sensor configuration to signal processing, from calibration to image quality optimization. Today, you will hear from 4 voices, each bringing a unique perspective, almost like the 4 riders of embedded vision. Together, they will show you what's next in software-defined imaging and why it matters now. Thanks for joining us and enjoy the ride.
Well, good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us for the future of embedded vision, trends, tools, and image processing insights. Let's imagine that we're working together on an embedded vision project, and we need to respond quickly to new requirements. So we're working in an industry where robust and reliable vision technologies are necessary and mission critical. Those industries could be imaging, medical, industrial, and for many of us here as part of this event, automotive. In the automotive industry, reliable vision technologies are mission critical. As we become aware of new requirements, we may initially turn to traditional ISP approaches, ISP being short for image signal processing. But in each of these 4 industries that we've mentioned, imaging, medical, industrial, and automotive, there's an increasing need to deliver results on time and under budget. And again, for many of us in automotive, we can relate to this. So perhaps in this regard, traditional ISP approaches are not as flexible as we need them to be. And then you add to that the custom hardware that would be required to complete our projects, and now we have a concern over cost. So what is the solution then for experts who are in the imaging, medical, industrial, and automotive sectors? You may be here today because you've heard about Solectrix. Perhaps you've seen the company's post on LinkedIn. You've listened to its Embedded Vision podcast, or you've met a Solectrix team member like I have at an industry event. You may have seen or heard about a tool set known as SXIVE, which stands for Simplified Extensive Image and Video Engine. Or perhaps you're just here today because you recognize that software-defined image processing is the future, but you're just not sure where to begin. No matter the reason, we're glad you're here today with us. And our goal is to demonstrate how you and your colleagues can leverage SXIVE to ultimately save time, reduce cost, and then enhance the experience that you have with your customers going forward. We're going to provide detailed instructions on key SXIVE components, which include soft ISP, calibration SDK, and sensor configuration tools, all with actionable insights that you can implement with your customers and team members today. My name is Carl Anthony. I'm the host of the AutoVision News Radio podcast, and we are joined by 3 expert presenters. Manuel Ott, who is the R&D manager at Solectrix, Dr. Sven Fleck, managing director of SmartSurv Vision Systems, and Uwe Artmann, CTO of Image Engineering. As this is a LinkedIn live event, if you have any questions for our speakers, just leave those in the comments because we're going to allow some time at the end to go through your questions. It is my pleasure now to introduce our first presenter, Manuel Ott, R&D Manager at Solectrix. And Manuel, the floor is yours, my friend.
Thank you, Carl. Thank you for the introduction, and hello, everybody. Today, we want to talk a little bit more about SXIVE, about rapid prototyping, and about, in general, how this can help projects. So let me share my screen. So today what I want to show you is basically why does a rapid prototyping system help any project? Why do we need that? Then I want to introduce SXIVE 2.0, give you a little bit of an overview. And at the end of my part, I want to present you a little bit a live demonstration on what does SXIVE do and what can we do with SXIVE on a very easy and flexible way. So let me go to my next slide. So first of all, how do regular projects work? From a perspective as an OEM spoken, you always have the project start and you have an end date in mind. And when you start with this project, for sure, you do your very best in specifying the amount of features which you want to have within your system. However, you as an OEM, you don't do all the work by yourself because there exist experts in the field. So you allocate the supplier, you find different supplier in the industry, and each and every supplier has the field of experience. For example, the first supplier does the camera head, does the sensor configuration and everything. The second supplier is the ISP expert, does the tuning of the ISP. And the third supplier does the CNN, so it's working with everything at the end. During the development, every supplier is working by themselves, having some intermediate formats to exchange some information. But in the end, you have the integration. So when the system integration starts, everything comes together. And from the perspective as an OEM, this is a very crucial point because then when everything comes together, you need to start with bug fixing, you have some error handling and so forth. And everybody and each and every company, every supplier did their best to develop the system as it was specified. However, since we find those systems getting more and more complex at the end, the integration gets more complex, the errors handling gets more complex. So how can we avoid that and start from the beginning with an integrated system or a system to integrate all the different parts with each other? And therefore, we can use a rapid prototyping tool. So that means in the very beginning, when you start with a supplier allocation, you have a tool with which you can troubleshoot, you can debug, even an expectation management. That means what does the sensor, the camera, the lens, the ISP, what is it capable of? And in the end of the day, also having an optical reference system from the beginning of the project. That means you don't need to wait half a year for an A sample or longer. You start with a very rough prototype. You have the images, you have the image quality, what you can expect in your later application. And the result is that you can lower costs, you need less time in the end, and for sure you have less trouble in the end for everybody, the supplier, the OEM, and everybody who's working on this project. So let me give you a short overview about SXIVE, and then I tell you a little bit more about the details. So SXIVE 2.0 is basically a combination of multiple software tools. The first is our soft ISP SDK, with which we have a GPU-based ISP. So that means we can input from multiple different sensors, the camera stream, so the raw images, having a colored image at the end. We can have input as live input, but also storage. And in the end of the day, we can just look at the image or store it. In addition to that, we have our calibration SDK that helps everybody to calibrate the intrinsic parameter of the ISP, such as color correction metrics or the lens distortion correction. Third tool, and I really like this tool, is our sensor configuration tool, a tool which Solectrix is using for multiple years now, which helps you or which allows you to access the sensor registers directly. That means that you when you start the project, you can see what kind of configuration is within the sensor, or you can even change this configuration to adapt it to your needs or even experiment with that. And also, we integrated the IQ Analyzer X from image engineering into SXIVE 2.0, which allows you to test the entire setup. But Uwe is going to show you more details about that later in his part. And finally, we also offer that as a hardware bundle. But our hardware bundle is more like a vehicle to deliver our software to our customers, since we found that many customers prefer having a ready-to-use system and not getting the software stack on their own systems. With our hardware bundles, we always ship our ProFrame frame grabber card. That ProFrame allows you to have a flexible front-end interface. That means that we support GSML interfaces, FPD interfaces, as a motion link, CSI, and even HDMI inputs. So that means we have a very flexible software toolkit on the SXIVE side, but also a very flexible hardware toolset on our hardware bundles. So let's dive in very shortly into the different parts of that. So our soft ISP SDK can be configured by different tools. One is just a configure file, which helps you to store configurations which you tested in field to have the same configuration in your lab. Then secondly, there's a graphical user interface, which you're going to see later on. And the third one is an API, which allows an algorithm which uses those images to interact with the ISP. That means if your algorithm is detecting some flaws in the image quality, it can still configure or communicate with the ISP to improve the image quality. We already have multiple cameras up and running from different vendors. There are way more available. If you have a specific camera in mind, just contact us, then we can have a look at this. And in general, it's a ready-to-use ISP with multiple different features. Our calibration SDK was built for easy use. So that means that users have an easy tool to configure the intrinsic parameters such as the color correction matrix or the lens distortion correction. Our idea behind that was basically that image quality experts or imaging experts are not everywhere in the company. So they are very rare resources. So with this tool, it is possible for more or less anybody to calibrate the ISP on their own very easily. And lastly, what I said, this is a really nice tool, is our sensor configuration tool, which is an open source tool. It can be downloaded on GitLab, and it allows you to communicate with the CRTS back channel with more or less any kind of sensor. The tool is a Python tool, so that is easy to expand. So that means that you can add graphics to that, for example, a compression curve or something which you already configured into the sensor. But it's also possible to read out registers on a cyclic base. And what is the nice part about this? This tool is NDA compliant. That means that when you have an NDA with the sensor manufacturer, you get the data sheet, you get the sensor registers, and then you can input that into the tool, and then it is ready to use. So let's switch to the live demonstration. I'm going to open the system. So there's a system which is connected to 4 different cameras, and I can show you basically how easy it is to use it. So first of all, the soft ISP is installed on the system. We have a prepared configuration of a Sony IMX 623. Sorry, wrong folder. I prepared actually everything, but it changed. The Q. What's wrong? I got it in a second. Here we go. So the soft ISP configuration on the IMX. Now it's easier. We have a config already prepared for that. And the input is a Pro Frame 3, and we output it on the graphical user interface. So we start with just that. So that means basically the entire magic is within the ini file. And when we start with the ini file, then you see the image coming out. So basically it's a live image. You can see me here in the room, sitting in the room, having some objects prepared in front of that. Then we can do the same with just to demonstrate how easy it is and having different vendors available. So we have a configuration for an ST micro sensor, also with a Pro Frame 3 input. Output is a graphical user interface, and it is connected to channel 2. Again, all the magic is within the ini file. It starts, and we have an image out of an ST micro sensor. And just to demonstrate that, we can even use more. What do we have? OmniVision. Channel 4. Yeah. Here we go. And whoops. And what I want to demonstrate with that is basically that whatever kind of sensor you're using, whatever kind of lens you're using, it is always it's always possible to see different effects on that and different behaviors of the sensors of the cameras. Channel 6. So those are the 4. So we have an Onsemi sensor, an OmniVision sensor, a Sony sensor, and an ST micro sensor, all running on the same system. As you can see, they all have different lenses. They all have different configurations, different calibrations, and stuff like that. And you can also see that we have the possibility in our ISP to change different settings, to have different ISP configurations. And also on the ST micro, we have also like a temporal denoiser. So we have communication established with the camera itself. Lastly, I wanted to show you our sensor configuration tool. Python. So we start that. It's an easy Python script. We open our intermediate SXIVE format and connect to the target. And now we are talking to the registers in the sensor itself. We can read that. So just to make that sure that that is clear. So those register names are obfuscated because I cannot show that publicly. But for example, if we have the mirror register in the camera head itself, I can talk to the sensor itself, do the configuration within the sensor. So that means with all this putting together, we have a very flexible system we can use and use anywhere in the project, whether it is in the beginning, where you are not sure what kind of camera you want to use, or as a safeguarding of the series software all the way to the end. So thank you very much for your time and listening to me. And now, Carl, back to you.
Thank you, Manuel. And I first met Manuel when we were part of our AutoSense and in-cabin conferences. So we were at the Auto World Museum in Brussels in the fall of 2023. And Solectrix was part of our press conference that we had at the Auto World in Belgium. Wonderful, just a beautiful museum if you've never been. But there's an upper room, and that's where we were having the press conference. And so me, as a podcaster, I'm covering the press announcements that are happening that day, and I'm taking notes. I actually flipped back to it, so I brought a prop. I'm not able to share my screen, but these are just some of the notes I took that afternoon in Brussels in October of 2023. And so keep in mind when you're covering these press conferences, I'm writing notes like crazy because I'm trying to do a write-up summary for the website or a podcast or something like that. But the one thing that, Manuel, that you had said in that original press conference that you talked about again today is this idea that image quality engineers are few and far between, that they're not necessarily at every company. Some companies may not have them at all. And one of the things you had said was that, and I wrote this down because it was such a good quote from you, is that we've designed SXIVE so that any engineer can use it, even if they are not an image engineer. And I thought that was a really excellent part about calibration SDK that you touched on again today.
Exactly. I mean, SXIVE itself is a huge software bundle, and it comes with a lot of bits and pieces. So that means that even experts can dive very deep into all the details. However, if those experts are not available, then it is still easy to use for more or less everybody in the company. And that was our goal. Like, that was one of our goals for that.
Manuel, thank you again. You are more than welcome to stay up to date the latest news from Solectrix by following the company's page here on LinkedIn. If you have questions for Manuel or any of our speakers, just feel free to leave those in the comments as part of this LinkedIn live event. Just drop your questions in the comments. We will leave time at the end to make sure that we get to each and every one of those. To provide a second perspective on SXIVE is Dr. Sven Fleck, Managing Director of SmartSurv Vision Systems. And Sven is going to share how to overcome challenges in image quality and what KPIs we need to consider. Sven, the floor is yours, my friend. Welcome.
Thanks a lot, Carl, for the very nice introduction. Hope you can see my screen. So I'm happy to be part of this activity today. So I will have the chance now to give a short introduction of what SmartSurv is doing and why basically image quality is crucial, first of all. So why these systems of Solectrix and also the imaging test equipment and approaches of image engineering are also relevant for the industry. I will also give a link to KPIs. How can you measure image quality? Where Uwe will, of course, give further details. So our role is basically to perform imaging inspection, imaging consulting. So our main, let's say, slogan is imaging TÜV or IQ TÜV. So what we do is we perform a deep dive with the OEM perspective. We help premium OEMs end-to-end specifying image quality requirements, assessing potential tier ones, and also helping in the series project up to task forces in the very end. So we perform technical deep dives with OEM perspective for 20 years now, both for AD and also in cabin systems, and especially for premium OEM that wants to get best or nothing quality to have brilliant image quality in the end. So with this mindset and experience, I would like to give you an overview why image quality is so crucial and why such systems of Solectrix and also image engineering are so relevant. So why is image quality so important, first of all? So here are two examples of images that are very different, obviously. As you might see, contrast is a key thing, subjectively already for a driver, but also for perception system. Which sometimes even leads to fatal accidents. So in this example, there's let's say a white truck in front of a white sky where contrast is quite limited, which is part of the image quality KPIs that we will target later. And if such low contrast image comes into the AI, to the perception system, it of course struggles, and this might lead to accidents. And such kind of accidents can, of course, happen in the form of decreasing true positives, so not detecting such events, but also to increase false alarm rates, like a phantom braking of an automated emergency braking system, which is also very important to prevent. So there are similar other safety relevant functions that all involve cameras and all involve image quality, like in-cabin airbag deployment or many, many more. So given this example of AAB, it all comes down to this simple graphics here. If you have, let's say, garbage in, there's garbage out of the AI. If there's not enough signal, not enough information content, you can do what you want. It will never be a robust system. And this is where we come in with image quality research, where KPIs are crucial to measure the input of the computer vision of the perception stack. So what are the challenges of such image quality related developments in automotive systems? So there are many challenges to mention. Of course, great image quality is the enabler to enable or to allow for AEB called stopping distance, for autonomous driving and all of that. So basically visualized in graphics like this, where a car stops in time. But what happens if this fails? What happens if the system degrades over time, for example? If there's sensor degradation, windshield degradation, sharpness loss, noise increase whatsoever? Or what is if certain scenes are not even considered in the development phase? This is just leading to the very complex topic of image quality. It's not just a single property of a camera system. It's very much scene dependent, it's temperature dependent, it's illumination dependent, and it's also dependent on degradation and lifetime effect. And all of that is, let's say, crucial to measure. And for this, we obviously need KPIs. And this brings me to the next slide. So basically, we want to implement this Vision Zero to prevent accidents and also prevent false alarms. And to this end, we first of all need to measure image quality. But of course, there's more. It's not just computer vision. There's even a further step, which is human vision, which is directly customer experienceable. And to enable brilliant image quality, it's a key element that is needed to also measure that. And to this end, the SXIVE system and also the image quality, the image engineering approach is a key way forward. So this also brings me to a quick link to IEEE activity, where we founded a working group on standardization called P2020 about automotive image quality standardization to exactly develop such KPIs. And what we see here, it's dual use more and more in such systems. It's machine vision, so perception, but it's also about viewing. But both use cases are crucial, and both are covered by the P2020 group, and both are covered by the SXIVE system and the image engineering approach. So just to give you a very brief overview of P2020, to also have, let's say, interested participants of this meeting giving a chance to join this group. I'll just give you a brief outline of the group. So the goal is there to raise awareness, first of all, of this whole need of image quality KPIs. And as mentioned, it can even be live or dead or live relevant. So the P2020 group meets multiple times a year, face-to-face at different locations, at different expert companies. And we have, of course, the opportunity for you to join. So please send me an email if you are interested so we can follow up later on. It's an individual membership-based approach. So both machine vision and viewing applications are covered. And just to give you a very brief feeling of what is developed in this group and what is, let's say, directly implemented by image engineering, using SXIVE system, for example, is one of the following KPIs. One is about resolution. Flickering is a key element where Professor Deegan is working on. And a very key element is so-called contrast detection probability or contrast transfer accuracy, which tries to implement an algorithm agnostic way to measure capability of a camera system on image quality level. And given this KPI, I would like to hand over to Uwe, where he will, of course, follow up in far more technical detail and provide a deep dive. So thank you.
Dr. Sven Fleck, Managing Director of SmartSurv Vision Systems. Of course, Sven talking about the P2020 working group. Sven, just a quick question, again, just for our audience. One more time, how can they get involved with P2020? How can they learn more information? What's the best way for our viewers today to go about that?
So there's no such obstacles like mentioned here. It's very easy, actually. So simply you can send an email with your interest and your background, and I will, once I found the slide, I will follow up with all the details to onboard you. So I get here a slide that is relevant for that. So it's very simple. There's also no cost involved. You can also choose how much you want to actively provide input, or if you just want to presently learn from the audience. It's about 400 members over the time now, and the first standard has been released now early this year, where the activity started in 2016. So this is also showing the massive amount of work that is coming into such standard developments. And exactly those KPIs are now, let's say, possible to be measured using the mentioned image quality approaches of image engineering, using, of course, SXIVE as a preferred option.
Thank you, Sven. And again, a lot of talented engineers and technologists who are part of that P2020 organization again. So the information here that's on your screen, IEEE membership is not required. P2020 is individual based, not entity based. Mm-hmm. And you can send an email to Sven for more information. Also, if you have additional questions for Sven on his slide, whether that's about more responsive AEB systems or addressing phantom braking, feel free to leave those in the comments to this LinkedIn live event. We will leave some time at the end to address each of your questions that you have for any of our speakers. As Sven mentioned, we'll turn things over to Uwe Artmann. Now, Uwe is the CTO of Image Engineering, and he joins us to expand further on the capabilities of SXIVE. Uwe and his team use SXIVE to establish workflows in camera characterization and testing that would just otherwise not be possible without. Near the end of April 2025, Solectrix and Image Engineering announced a new strategic partnership that was focused on the latest version of SXIVE that we've been discussing today, that we started with Manuel's presentation on. And this partnership really pairs the capabilities of SXIVE with IQ Analyzer X. IQ Analyzer X, that's a state-of-the-art image quality analysis software from Image Engineering. Please welcome Uwe Artmann with more. Uwe, the floor is yours, my friend. Good to see you.
Thanks, Carl, for the introduction. And the nice thing, if you are the last speaker, the floor is prepared. Manuel gave a great introduction. Sven addressed a lot of topics that I also got to bring up. So my job is now to wrap it up and to show specifically how we at Image Engineering can make use of the SXIVE system, but also how we go into these KPI-driven development and how we see things. So maybe just a very briefly, a quick word about Image Engineering. So we are a company that is dedicated to calibration and characterization of cameras. So started 30 years ago with testing the first digital cameras that came to the German market, and now a significant driver also in the automotive market. Wherever cameras are used, we work with them, and that's where like SXIVE system is a great enabler. As it's not only for one small part, it's actually for imaging in its general usage. So we are in Germany and in Kerpen, close to Cologne. And what is, I think, we heard about standards, so IEEE P2020, and that something that we made to our DNA at Image Engineering. So there's a huge variety of different organizations that care about standards for testing, and we are proud members of many of these activities, because we always say there shouldn't be any like magic numbers. I mean, Sven said KPIs are a matter of life and death. So you wouldn't rely, or you shouldn't rely such heavy decision on, hey, Uwe said thumbs up or thumbs down. That's something you should do that on proper measurement, and that you really understand what's the workflow, where did these numbers, where did these KPIs come from. So we are active in ISO and IEEE P2020, what you've seen. We are founding members of VCX Forum, which addresses phone cams and some mobile phones and webcam, but also like EMVA 1288, which is a machine vision standard, where we are active members and contribute. And we make in our lab, we make use of that. In my role, or in our role as at Image Engineering, we also we often get deeply involved into projects. But what happens a lot, and that is my my experience, that for many, testing is seen as an annoying extra that the customer asks for. So yeah, let's just develop a camera, and this testing is just, you know, on top at the end of the project. Yeah, we also do some testing so that actually the customer will sign off the project and we can move on. So that means there's a trend to just, or many just do some very simple tasks, put some easy targets in front of the camera, try to find something, and then at the end they go on the road, they test, and then at the end they go on the road, and then they might see something. But what does that mean? If you, at the end of the change, so you started to say, okay, design, so what do I want to do? And then you start to source the sensors, the lens, Manuel talked about that. But then also you put everything together so that you get it actually working, you configure it, you tune it, and then comes the validation, which is critical and important. But if at the end of the project something happens, what do? I mean, ideally, or you find out, hey, the choice for the sensor was not good. Okay, technically you need to go back all the way back to sourcing and start again. In reality, what happens that you have the very tough decision to say, okay, either I tell my customer the project is delayed by a year if I go back to sourcing, or I have to close my eyes and just say, oh yeah, it should somehow work. And as we learned, this is about life and death, and that shouldn't be based on, let's somehow push it through. So what we see and what we think is very important, that throughout the project you have proper testing. And proper testing doesn't mean necessarily what you see here. So just putting a color checker in front of a camera, or using a very outdated ISO 12233 test target, that's an indicator. With that you might find some things. That is, I don't say it's not useful, but it's not proper testing where you really understand things. So what you need to do is, at the very beginning, you start to test properly. You get the right KPIs that you need in that stage. And that can be, and that's where SXIVE is a great enabler. You don't have to wait until the hardware development team has done a job and has something on the table that you can start with testing. With a SXIVE system, you can do that right at the first stage, and each time you make a step forward, you also go through rigid test program, so that at the end, when you validate it, it's really just validating, really confirming of things that you already know, that your system is tuned to the best possible and does what you expect what it should do. Okay, that's as a general remark. We as image engineering, what we offer, what we do is we test cameras, obviously, but a task that we have quite regularly is that an OEM says, okay, I have the potential choice between these 3, 4, 5 different sensors. Please, can you test that for us? And what that means, if you have the task, and a lot of people in this business know that, okay, then you have 5 different tools, 5 different software stacks, because you always use the demo equipment and so on. And then the bring up is a massive component of that. And then you have to, every software is different. That takes ages. If we lose, and what we do at Image Engineering, we use the SXIVE system, so we can get exactly as Manuel showed. So you can envision that. He quickly stepped through 4 different sensors from 4 different suppliers. Imagine doing that with the 4 different tools that these suppliers provide for their partners as a demo equipment. You wouldn't be able to do that. With the SXIVE system, you just switch. The secret is in the INI file, but if you have the INI files, you can just work with different sensors on the same setup. That also allows automation. So we can test sensors, camera configurations much faster using the SXIVE system, because we can quickly test as Manuel showed. So we had 4 different sensor suppliers and technically got an image from them. That means we can also test them automatically for the highest standards of what we have these days on image quality testing. So that's a great enabler. Something that is also, we're always talking about the lab, but something that we did, for example, this is the quick and easy setup where we took SXIVE into a car, a battery pack, and then we are able to record videos on the road. You don't need the big demo equipment part. It's very simple. So you can put that in there. So you have an automotive grade camera on the road at the very beginning of your project, because it's lightweight, it's easy manageable, and can do that even in a normal car. So no big. So it's really a great enabler for these kind of things. Sven was so kind, also talked about and already gave the introduction to how important KPI image quality is for testing. And it's our here at Image Engineering, our profession to do that. I can easily talk for 2 days about these, but I want to take a small part of here, and that's what Sven already mentioned. I think a relatively new metric, but a very critical and very important metric, that is the CTA, or contrast transfer accuracy, which has been introduced with the IEEE P2020. That is a metric where you measure how well can this camera reproduce a certain contrast at a given intensity. So with that, you can see, okay, you have low contrast, high contrast scenes. So how can it handle that? But also that over intensities. And that's a great enabler, or can tell you a lot about the camera system. So you see that here the result of such CTA measurement is a map where you have luminance versus contrast, and then in color encoded the CTA. CTA, a value of 1 means it's statistically perfect differentiation. You met exactly the contrast that is in there. So that's where you want to be. And the lower it is, the more it goes towards 0, or bluish here, the lower that is. And if it reaches 0, you can't differentiate that. And you see that here in this example. So there's like a car, and the headlights, they create a huge contrast. So that then in the upper region where it's yellow, so that can be well recreated. But you see also on the lower left in the image, there is some rubber parts on the tarmac. So black versus black, low contrast, low light. That's where the challenge is. That's something where it's really important to get to know about your camera system. And that's where a CTA measurement can help. Just some examples from our work. So you want to know for a camera like the low light performance. So that's the left region. That's where you have a look in your map, because that's a low light and then a different contrast. Very important, as you have like at night emergency braking, you need to see beyond headlamps typically. So that's important to check for that. But you can also have just low contrast. So then you are in the lower part where you check your map. So you see that here. So there are some pedestrians on the left, and they form a very low contrast towards the background that can cause some trouble. Or with modern images where you have HDR, you see the car approaching from outside the tunnel into the tunnel, and in that region where it enters the tunnel, you get a lot of noise and low contrast on that car. That is an artifact from HDR merging, and that can be actually tuned. That's something that you can find from the results, and that's very critical that you do that in the lab and not later on the road. Or highlight performance, you see that here, 2 cameras. Top, obviously, poor highlight performance, colored highlights, details gone. The lower handle is much better. The sun is just a circle, everything else is visible. And you see on the right how you see that in a map, captured in such map. So how can you get that? So there's 2 ways to get that in the standard. One is a spatial recording, where you place many different luminance patches to the camera, show that to the camera so that it can capture that. So spatially distributed luminances. That's great if you have a full ISP, if the processing, also if you want to see effects of like local tone mapping and such. But there's also the temporal recording, and we, for example, do that also over temperature. So what we do, we have a control PC that talks to a controllable light source, and that talks to a climate chamber, and that talks to the SXIVE HT in our case. So now we can have scripts and automation that does this measurement, so we can do measurements for different cameras. And all of this, or 90% of the code used, can remain the same if we switch from an on-semi sensor to an OmniVision to an ST sensor. And that's a great enabler, so that helps a lot in the lab to do testing. And then a result could be something like this. So you see these maps over temperature, and there are a lot of different things that we can see. Disclaimer, this is a non-optimized, off-the-shelf camera with automotive-grade sensor, so not optimized in terms of setting, but exactly that's what we can now see. So we have reduced low-light performance with increasing temperature. Yes, more noise means lower low-light performance. But also we see a noise and contrast loss between the HDR exposure, which gets significant the more ambient temperature we have. But we also see a bug in readout, and it's great if you find that bug now in the lab and not on the road. As Sven said, it's about life and death. Okay, so in the SXIVE system that Manuel talked about, there is also the IQ Analyzer X. So the tools that you have just seen, that's what we have in our lab. I'm happy to talk about everything, how we implemented that, but what you can use directly is also the IQ Analyzer X. That is a software that allows you to read video files, that reads our image files, and then to perform certain different analysis. So I can just to show you, so I can go here and then add. Let me just pick some. Just an example image. So I have here a color checker. You see the software detected, okay, what shot is it? And will now also analyze that. So it will just read the image, automatically detect where's the target, where's all the ROIs, and then I get my results. Where for this example, where I have now a color reproduction measurement. That's also where I can now go into it and then understand a little better which colors do cause some issues, which colors might have some higher color deviation and these kind of things. So that's an easy or much better to understanding about that color. Something that it can do as well is, and that's what you have seen in the screenshot from Manuel, is, for example, our T42LL. So that's a test target. You can see it here in the top right, which contains a lot of different structures, especially when it's about ISP tuning. There's always that you need to find a trade-off. How much noise do I leave in the image in trade-off to the texture that might be remaining? How much desaturation do I allow for the colors? And what is the actual level of details that I can resolve? So for that, we have this multi-purpose target where we have a lot of different interesting structures, from easy things like color and gray patches for noise, but also like dead leaves patches for texture measurement, or cement stars and edges for resolution measurement. just in this example, I got now all the different SFRs from that, and I can also have a look at that. Here, for example, I just have from one image, from one dead leaves patch, the SFR that I just extracted. I added a couple of images at different sensitivities with different tuning, and now I can directly compare and see, okay, this kind of camera with different settings, I got a loss in texture loss. So I got a lower SFR depending on my tuning. And I can at the same time from this image also get, like before, the color and evaluate the color at the same time, but also see noise, SNR, and other very important metrics that I might need for my evaluation. So this software is then available on the SXIVE so that you can capture images with your SXIVE and get that. So it's a great help then and complementary to the tools that Solectrix already provides. Have that so that you have a complete tool set to get to best possible performance of your camera system. And yeah, as I would always like to have it when I use cars with camera systems, that most things have already appeared in the lab before you go on the road. So then you have peace of mind. It's on the road. It's just validation and not part of the development. So that gives you a better, more stable timeline and actually a better product at the end. So with that, thanks a lot for listening or for this presentation. And back to you, Carl.
Thank you, Uwe. And again, near the end of April 2025, Solectrix and Image Engineering announced a new strategic partnership that's focused on the latest version of SXIVE 2.0, which we've been discussing today. And that partnership then pairs the capability of SXIVE with IQ Analyzer X, a state-of-the-art image quality analysis software from Image Engineering, which you just saw a moment ago. Uwe Artmann, CTO of Image Engineering, had the opportunity to see Uwe just a couple of weeks ago here in Detroit for our 2025 edition of AutoSense and In Cabin. And Uwe, we had talked about this on site at the Huntington place. You brought it up again here today, but that testing is seen by many as an annoying add-on which is needed for the customer. I'm reading verbatim from your slides here. And then final validation is based on test drives and hope that nothing shows up. I really think that really just summarizes everything so nicely, Uwe.
Yes, and unfortunately, that's really the experience that it's some extra, but it is part. I mean, I've seen projects where we had to rush in, and I think Sven, as consultant, has something that you have an emergency task force group at the end of the project that tries to solve some issues that came up very, very late in the project. And I mean, a lot of people have that, and if it's sometimes it happens, it's unavoidable that things come up. But these kind of things, if you have an IQ issue at the very end, most likely it's avoidable if you have tested properly beforehand, and not this. I mean, you have seen so taking. I mean, I've seen so many times where people point the camera towards their window in the office and use that as HDR testing. Of course, it gives you a first initial idea, but it's not a proper testing. And yes, testing costs time, therefore it costs money. Yes, but there's no way around that. Oh, I think I lost my microphone.
As Uwe is finding his microphone, we did have one question come through. If you'd like to leave a question, please do so in the comments there as part of this LinkedIn Live broadcast. We've got a few minutes now just to ask a few questions of our panelists. Our first question comes, and I believe this is going to be inspired by the slide that Sven shared earlier, but why is it important to address more responsive braking times or better braking times for AEB systems? Or why is it important to address phantom braking? And then maybe to add on to that, in addition to that, is that we're talking about the future of embedded vision. So does embedded vision, or how can embedded vision maybe help develop a more responsive AEB system or prevent phantom braking? I'll open this question to any of our panelists, and maybe Sven, we can even start with you since it was on your slide.
Oh, sure, Carl, of course. So I guess phantom braking is, let's say, also a dangerous situation where the car behind you might hit you, and it's also unintended feature. So it's also covered by the SOLTIF process. Formally, it has to be avoided, and we want to create robust systems that work as intended. So we want to, in the end, avoid surprises and stay ahead of the wave, and using KPIs to enable that to have pre-development and early development, and not just, let's say, identifying issues in the field.
Yeah. Uwe, Manuel, anything to add to that?
Maybe, yeah, I can add. And Sven, you had a nice slide about this truck that was just formed, the white truck that formed low contrast towards the background. And I mean, I would hesitate to say this is an edge case. I think this is a normal case, but
Yes.
that is where it's actually important to scan through. That's why I enthusiastically say it's important to test, because only if you really scanned through all combinations of certain contrasts and intensities, you can be sure that you covered this. Because even if you go on the road and you say, hey, colleagues, go on the road and drive for a while, it's not the possibility that you meet such edge cases is quite low. But I mean, the edge cases, that's what makes it interesting and what really drives the differences of a good system and a potentially failing system. It's not that they fail when you have nice overclouded, no direct sun, bright, a black car before the background. That's not where the issue is. The issue is nighttime, white truck, or whatever, and that's important to test that properly in the lab beforehand, and not just that it's by luck. It shouldn't be. There shouldn't be no luck involved in this process. It should be intentionally testing.
And this even involves things like, for example, degradation of such systems in the field. So this is also important, like Uwe indicated, like temperature-based testing and all of that to avoid surprises. And still, it's a risk because of the data drift that the AI is stimulated with.
And what Uwe showed earlier in his slides is that you can, with SXIVE and the image engineering tool set, you can use the same system you're testing in the lab with all the measurement. You can take this, put it in the car, and drive around with that and see like what is the result of your testing, your tuning, and stuff like that. One in the field, in the lab, but also in the field in the car.
In just the last couple minutes that we have here, one more question came through. We all know the term software-defined vehicles or software-defined cars, that is, or SDVs for short. That's the term at the top of our automotive lexicon today. So how does SXIVE complement software-defined vehicles, and how does SXIVE make the ADAS feature set of an SDV safer and more optimized?
Maybe if I may, then I try to answer the question. So basically, what in this entire field you have all the different systems interacting with each other, and one is for sure to make the vision components more safe. So that means that you have like safety goals which need to be met, and having those safety goals, you need to add some kind of measurements into this vision path. And with SXIVE, since we have a GPU-based ISP here, it is easy to put those measurements into the system already very early in the project, and then have what Uwe said, like a system which I can test. So that means also I can test whether or not my implementation is going to meet with those safety requirements, and have what Uwe said earlier. It's not that I intend to meet those safety requirements, and at the end of the project, when I'm testing them, I see that, oh, we did some mistake or some error, and that we need to change something. No, it's like really good to integrate that into SXIVE on a software base to see whether or not those measurements are working, and then port this into the hardware. And so there, SXIVE can also put an advantage to this kind of systems.
Thank you, Manuel. And you're always welcome to stay up to date with Solectrix by following the company's LinkedIn profile. For German speakers, the Solectrix Image Processing and Embedded Perspectives podcast is available on Spotify, Apple Podcast, Amazon Music, and more. The podcast explores innovative use cases for embedded electronics for listeners who are passionate about the technology. For Manuel Ott, Uwe Artmann, and Sven Fleck, and on behalf of the entire Solectrix team, thank you for joining us for the future of embedded vision, trends, tools, and image processing insights. SXIVE is your trusted companion in this era of software-defined image processing. I'm Carl Anthony of the AutoVision News Radio podcast, wishing you a safe and productive rest of the week. Thank you for joining us.